We have entered the era of agentic AI, where models are no longer limited to answering single prompts. Instead, they operate in continuous loops, autonomously writing code, managing developer tools, and coordinating complex workflows without human intervention. Maintaining these long-running tasks requires an immense digital memory. New models like DeepSeek V4 and Kimi K3 utilize context windows of 1 million tokens or more to keep these sprawling autonomous chains of thought from collapsing. This line graph shows a conflict between two opposing trends. While the per-token price of AI has dropped by a factor of 10 every year, total enterprise spending is currently exploding. Organizations are finding that because agentic usage is growing so fast, monthly cloud bills are reaching tens of millions of dollars. A $20 monthly consumer subscription acts as a loss leader. For an enterprise developer running heavy agentic workloads, the true API cost of that compute would reach hundreds of dollars a month, a gap that makes high-volume cloud usage unsustainable for many organizations. With infrastructure costs now reaching a tipping point, the current trajectory of AI development depends on a shift in how software interacts with physical hardware. The true economy of a large language model is determined by physical constraints hidden inside the server racks of a data center. Modern AI performance is limited by memory bandwidth, the specific speed at which data travels between the processing chips and the memory banks. During the prefill phase, a GPU is highly efficient, digesting your entire prompt by reading thousands of words simultaneously. But during the decode phase, the model must produce single tokens one by one. The process becomes agonizingly slow. The GPU effectively spends the majority of its time idling. It is waiting for the model's weights to be loaded from high-bandwidth memory, which moves far slower than the processor can think. Mastery of this restrictive physical pipeline has become the primary focus of AI engineering. Forcing data through this bottleneck faster is the only way to lower the cost of intelligence. Because hardware physics are difficult to change, developers of models like Kimi and DeepSeek are using a series of architectural hacks to bypass the bottleneck. The first technique is batching. Processing hundreds of requests simultaneously distributes the heavy cost of loading model weights across many users at once. The second hack is a structural change known as mixture of experts, a technique that allows models like Kimi K3 to scale to 3 trillion parameters. Instead of activating every brain cell for every word, the model only uses a tiny fraction of its network, activating just 16 experts out of nearly 900 for any given task. This massively reduces the computational load. The third algorithmic hack is memory compression, which is central to the DeepSeek V4 architecture. Using compressed key-value entries, the model shrinks the data's footprint before it enters the cache. Then, by applying mixed precision arithmetic, dropping from complex 32-bit math to simple 5-bit numbers, the pipeline moves even faster, processing more data with fewer resources. These three hacks, batching, expert routing, and compression, turn a physical hardware limitation into a high-efficiency engine for autonomous agents. These efficiency gains have resulted in a 10-fold annual decline in inference costs at a fixed level of performance. The price difference is staggering. DeepSeek V4 flash input is currently 97.2% cheaper than GPT 5.5, despite both models competing at the performance frontier. Technical benchmarks show the quality gap between these open-source challengers and proprietary systems has narrowed to just 3.3%. To escape rising cloud bills, enterprises are shifting to hybrid and edge architectures, running highly optimized models on their own local hardware where they can control inference costs directly. These economic realities have made open-source models the default choice for development teams. In late 2025, open models already accounted for roughly 1/3 of the token volume on platforms like OpenRouter. Success in the next phase of AI development will be determined by how effectively engineers can master the physics of memory to make intelligence affordable at a massive scale.